Session is going to be led and chaired by Carolyn van der Bogert, who is from the University of Munster. We heard her speak earlier today, and she is also the ESA Integrated Team Member for HRE Lunar Science. So welcome back to the stage, Carolyn, and if you want, I can also introduce your panelists. Perhaps you're going to do that yourself. Well, your panelists are Clive Neal, University of Notre Dame. We've got Abigail, Esric, back up on the stage, Gary Lai from Interlune, Antonino Salimeri, who is from Lunar Policy Platform, LPP, heard him speaking yesterday, and Gerald Sanders from Esric. Thank you, and thank you, Carolyn.
So I would like to welcome everybody now to our panel discussion about challenges and opportunities in resource prospecting. And maybe I'll give everyone an opportunity. We'll just go down the row here. If you could just reintroduce yourself very briefly to the audience, what your name is, of course, we sometimes know, Jerry.
Hi, Gerald Sanders. I work at Esric. This is my third day there. Before that, I did happen to work for NASA for 40 years, leading in situ resource utilization for 25.
I'm Gary Lai. I am a co-founder and the Chief Technology Officer of Interlune, which is a commercial company based in the United States, focused on space resource utilization, especially starting with helium-3. And before co-founding the company, I spent about 25 years primarily developing reusable launch vehicles, many years of that at Blue Origin.
Hello, I'm Antonino Salimeri. I'm director of the Lunar Policy Platform. People know me here as the lawyer.
Hello, I'm Abigail Calzada. I'm senior researcher at Esric, and previously I was working as a lunar expert and mission planner at a private company.
Clive Neal, a 40-year lunatic, and I'm passionate about all things about the moon. The moon, not a moon.
So I'm extremely happy to have all of you here on the stage with me so that we can talk about, I'm focusing in on a couple of general topics. Data gaps, that's kind of one of the going themes that we always keep talking about. Data acquisition and sharing, we heard from some of you individually already about the importance of thinking about that and also doing the legal framework for that. And then I want to kind of close up, if we don't go over time, on how are we doing on our progress on prospecting. So I think I'm going to start with sort of a little kind of a trick question. And I'd like each of you to just say which data gap, singular, is most pressing from your perspective. And just give me like a quick 1.5 minute answer. So why don't we start with Clive and we'll work back our way down the panel. One answer, Clive.
One gap.
One gap. What's the most pressing?
Ground truth data.
Ah, clever. That's a very clever answer.
Okay. So I don't want to repeat the ground truth that I think that actually is really important. So I'm going to say structural geophysical data.
Okay.
I'm not a geologist, so I'm going to give you a different answer. Who does what in prospecting?
Okay.
I'm going to give a slightly longer answer, but it is also ground truth data, but obviously for Interlune, for helium-3 specifically, it is ground truth data validating that the theory around the correlation between titanium dioxide and helium-3 survives, goes all the way out to the very highest concentration titanium-rich areas on the moon.
And I'll round it out by basically saying not just ground truth data, but in particular water resources in smaller permanently shadowed craters, because that is critical to understand before we decide where we're going to build our infrastructure.
Okay, so I think you've all realized that the panel here, we're talking not about orbital data per se, we're talking about ground data. So the question that follows that is, what concrete actions are being taken? I mean, this is kind of part of this whole week here, but what's actually preventing us from already this year having some of these ground truth points achieved?
Well, I guess I'll start on this side. So first of all, a tremendous amount of activity is going on. I think what has prevented us up to this point has been some of the failures of the landers themselves. I mean, we had Prime 1 that was aimed at going to volatiles. Viper mission was delayed because of a lander issue. Lupex, which will look for water ice as well, is semi-delayed based on the Indian ISRO lander being used for something else, sample return, I think. So I've seen tremendous progress in the number of instruments being developed, the number of missions being proposed and trying to have flown already. But I'll leave it to my colleagues to say why that hasn't panned out yet.
You can go in this direction.
Yeah, or Clive is grinning. Would you like to jump in, Clive?
No, I'm going to let Barry go.
Okay.
Okay, well, first off, you asked us to name just one,
Right.
which is very hard to do. I don't want to. There is a very high importance on the orbital data as well, but the ground truth data is really a means to calibrate and prove that the orbital data is real, because it is obviously much more effective to build a very comprehensive map of resources from orbit. You just need to have data points that you can anchor it to on the ground. In terms of what's limiting, I do agree there's a lot. We're on the verge, and maybe it seems like we've been on the verge for several years of a lot of activity happening, but that is about to explode. Certainly, Interloon, in order to get that ground truth data, we are having to design our own payload to pay for a lander to go over to a very specific location, the highest helium-3 area on the moon, which is a financial and business risk as well. So, if that data were publicly available, it would really require there to be an international a scientific agency focus on the mid-latitude Mare regions, which we don't typically tend to see. It's mostly just the poles where the science missions go.
So basically what you're talking about now is that you have now a sort of a catalyst for a business model to now do your own mission to get that ground truth that you need. Or you mentioned in the first day also a desire to purchase higher resolution data, which in theory could come from an agency if any agency assets were able to produce that high resolution data, or you could get that privately. So I think that now I'm kind of answering my question a little bit. We've reached the point finally that we're at a tipping point where I think we're going to see a lot more activity happening before the next Space Resources Week. So I see Clive grinning down there, and so I'm wondering how...
He can't wait till
right,
the end.
He can't wait. How do we get this going more in a collaborative and international way that involves also the space agencies?
Okay,
Or not?
let's get real. We've got rovers, we've got Viper, we've got Lupex, there's the Rashid 3 UAE rover, there are other micro rovers, and they're totally uncoordinated in what they're trying to do. And we need a campaign. And if you don't have a campaign, a prospecting campaign of coordinated missions, doesn't matter where they come from. And Gary is exactly right. They're having to fund their own prospecting mission because the direct data aren't available. And what we can do as part of that campaign is to pull together through international collaborations, because it's expensive to do all these missions. We can do it with commercial collaborations as well. But there needs to be a coordinated prospecting campaign, and I'll keep using that word campaign, and we've got to get out of this mission mindset. It's not a mission, it's a campaign of missions, and we have to get that in order to make progress, to get the ground truth data, in order to get to what Carlos Espejal said earlier on about we need to get to be able to say what the cutoff grades are. So that is when you can go to investors to give the credible data to them that they can then, you can then get backing to go mine the resource. But this is where we have to come together as an international community, not just space agencies, not just commercial, but we need to coordinate it so that we get the data efficiently and effectively and share it properly.
Right, yeah, sharing is something we're going to come back to in great detail about the data in particular. But Antonio, you're involved in the UN committees, and in terms of like supporting more international collaboration, do you see that in a positive light? Are there structures that exist or are being made that can be supportive of that?
Yeah, absolutely. Sorry, Abby, I know you wanted to jump in.
I'll get back.
But yes, so at the United Nations Committee on the Peaceful Use of Outer Space, there is a few initiatives that now have ramped up in the field of lunar activities. One of them is the Action Team on Lunar Activities consultation. It was established in 2024 after the first UN Lunar Conference that were organized by the UN Office for Outer Space Affairs, with a mandate to examine how do we improve consultation and hopefully also coordination of lunar activities. And I just came actually from an ATLAC meeting. That's why I just arrived in the room right before this panel. And there are now recommendations being prepared on potentially establishing an international lunar mechanism that could then be discussed and negotiated and created next year and potentially announced at a Unispace 4 conference. Then there is the UN Office for Outer Space Affairs has a project called One Moon for All. Through this project, essentially UNUSA gathers different stakeholders for high-level informal dialogues that can help inform the work of the diplomats and the policymakers to go into the right direction and to make sure that we can do this in an informed way. And that's going to happen through this lunar conference. So we did the first one in 2024. Then there was last year there was one on commercial lunar activities, where we brought a lot of the companies that are in the room here to talk about their needs and explain what do they need from the UN and how they can contribute. And this year we're going to have a third lunar conference. It's going to be the biggest ever, 3 days, and we're going to focus on this international lunar mechanism, having space for member states to discuss, and then later on for civil society and industry to chime in. So I think there is a great framework in place. We are living really at a special moment in time to really make this happen in the right way. And I'm very positive, I have to say.
Yeah, that sounds very, very optimistic and positive. And so with Clive's initiative, sort of from the science and engineering side, coming together with some of the more policy-based initiatives, I think hopefully we can meet in the middle. You have a comment?
That's why I hang out with the lawyer.
Right.
Yeah.
I mean, we got Clive at the UN just a few times now, and they didn't kick him out, so that's already great.
It's also a positive sign.
Diplomat in training, yeah.
I think one of the big issues or differences of the past versus what Clive and others are talking about is if you look at the standard approach for, at least at NASA, with the CLIPS program, it run out of SMD. They have a PRISM call that's based on pursuing a particular science theme, and then you kind of prioritize different science themes. It's kind of one-off type of thing, and where we're talking about and why you're seeing Gary having to do his own mission is the pace of how we need to do this needs to increase. We can't just do this call once a year. Is it a science theme? It's got to be more focused. It's got to be more commercially driven. And the current, at least on the US side, was never really set up to do that. And it will be interesting to see how other space agencies react to that kind of an environment that, okay, science-driven exploration is good, but if we really want a permanent presence, we're going to have to think about the technologies, the resources, the infrastructure. So that's something that I think everyone on this panel is probably seeing, that we got to pick up the pace.
Right, and I think by this time next year, we're going to see something radically different. We'll have some additional stuff to discuss that's happened because of this new impetus from NASA's new program. So I want to kind of step back to, Clive mentioned data sets. I mean, we have a lot of data sets that are already available. And so, Abigail, I wanted to ask you about how you're having a new look at these data sets as you're working on this resource model, to give us a little perspective on, is there a lot of room for improvement on those existing data sets?
Yeah, I mean, I think that there is always room for improvement in everything. So yeah, no, I just want to point out that something that I think that is really important that Jerry said before is like, I mean, a few years ago, this conversation about data, it wouldn't be as, we wouldn't have an entire day of prospecting and exploration, an entire panel of data. And that is a big change because actually or at least it's my field, I've been in the Space Resource Week since the very, very beginning. And it's like, I see that it's a change. And it's a change and like things are getting serious. So I don't want to think it was the limitations. It's like, right now it's like, it seems that everybody took the sleeves up and it's like, okay, now we are going to work. And our data is like, we can improve in so many ways. We can improve in having more data with better resolutions, different type of instruments. We are relying on the instruments that we have, but we still need to explore different type of instruments that we haven't used on the moon before. Maybe there are new things, new techniques that allow us on the ground and orbital, in everything to improve that. And not just that, I mean, in the previous sessions, we saw many companies that are actually attacking the data set, attacking in a good way, from different perspectives, like using new tools for processing, automatization, the things. So that is really important because that will make us to do everything faster, in a more efficient manner, cheaper. And I think that that is a turning point that just a couple of years ago, it was impossible even to imagine. So I think that, as it was said, we are living in a really exciting moment, and things are getting serious now. I mean, and I always say, I make the joke, it's like when lawyers are in, it's because things are getting very, very serious.
You know, one thing about data sets is, and this conference is shown it quite a bit, you're seeing a lot of really interesting instruments, and you're seeing a lot of very interesting mission concepts, but they're discrete. There's like a certain instrument on this vehicle at this altitude for this period of time, and how you pull all those data sets with different resolutions, with different altitudes or locations, different factors. That is also, I think, a critical aspect that, with Clive in the coordination, it makes sense now that if you can only fly one instrument in one orbiter, how does that fit into the bigger picture, making sure that it's done right? I think that falls into that category.
Yeah, we got to break the mold. We got to get out of the mission mindset. Okay, we know. For example, we take water ice, we know what we don't know, and we need to go know it. So if we're going to do a campaign, what do we equip 20 rovers with to go get the data from different locations? We know that. We've seen the instruments. It's bringing that together in a production line. Yes, it's going to be expensive, but if you do duplicate builds, you're gonna save on the duplicate builds. So, and it requires the commitment from not just one space agency, but a collaboration between space agencies to be able to do that.
Right, and I'm wondering, Gary, if you could comment too about the interest of the commercial sector in maybe contributing to such a model.
Yes, absolutely. So, but first, before I follow that, I had a thought on the amount of data. There is a lot of data. It is primarily data of interest to answering scientific questions. But there is a dearth of data. There is more data needed if you are trying to approach it from the standpoint of resource utilization. For example, you can say there is a certain ice content that in a particular location, but what is the actual form of that ice in the way that it could be, you can think of it in terms of extraction. Like if you're a mining company or a resource utilization company, you need different kinds of engineering data as well. In terms of your question of how we contribute, I mean, certainly you can't get around the fact that for a commercial company, there is a business model. You have to make money, right? So if you make an investment, certainly we want to abide by all data sharing provisions in international law, but in order for there to be a financial incentive to invest in extracting data that is, there has to be some level of protection. So I think from our standpoint, we would certainly love to share as much information as possible, but we also need to justify a return on investment, whether that is having tiered data releases or even embargo data releases over time is another mechanism. Wait 5 years and then it's publicly released.
Or lower resolution, It's like the satellite imaging. I'll give you the 5 meter per pixel map, but I'm holding the 1 centimeter per pixel map.
Exactly. I wanted to follow up, if I may, on a few of the points that we mentioned. So just the last one on data sharing, absolutely agree. And that's exactly what we are looking to discuss with ESRIC in the project that we're going to do on information sharing for resource prospecting. What are the solutions that will allow us to take into account legitimate commercial interest with the need to organize somehow how do we share the data, because it's also going to be in your interest to share it if others are going to do the same. And then the collective view of the data will be much bigger than the sum of its parts. So I think the tiered approach, the lower resolution, the embargo, there are all potential solutions that complemented together can deliver us where do we need to be.
Well, I think another aspect that a lot of people don't think about is the time of the data. Yeah. So, a typical science mission, the PI holds the data for a year and plays with it on their own before it's publicly released. Gary's going to hold his data until he gets a chance to sell it or some venture makes it worthwhile.
There will be a press release.
Yeah, there'll be a press release. So it's not just, am I collecting the data, it's how fast am I getting access to that data and using it.
Exactly. And another point of what Jerry mentioned before on the compatibility, right? So there are many data sets that exist already. That's what I'm learning from all of you guys. But it's difficult to put them together, right? Because they look at different resolution, different places. They've been taken with different instruments, different goals in mind. So I think at this point, someone needs to take the lead and set the standards on how do we collect the next data and how do we organize the data that exists already so that they make sense for reserve estimation. We have to have somewhere to find and someone to follow, and then the rest, I think, will compile it.
Right, so maybe Abigail, is that part of the motivation for the lunar resource model?
I mean, the main motivation for the lunar resource reference model is like the fact that we realize that most of the data are scattered through different repositories. They are, as for some people, are difficult to actually access to it. And the most important is experts know how to find the data, how to work with the data, but actually who make the decisions, they are not always the experts one. So actually we have to have a tool that allows to transform data and information into knowledge. So actually something that is easy for also the decision makers to look and understand. And it's believable, and a big part of actually this platform is not just provide the data, but also provide track of from where this data come from, what are the process that has been followed, who is responsible of the data. So actually you have somebody who says to blame if something is wrong, that probably, I hope everything's going to be fine. But actually you have track of the data, the uncertainty that is linked to that data, how much we trust that data. It's like we cannot just be blind and say, oh, this is the real truth. No. And actually from that, it's like when we can start to thinking how we can take what it will be the next type of data that will help to decrease this uncertainty. What is the most efficient way to actually using our resources, our money, and our effort too. So that is the main part, actually. Make something accessible for everybody, even non-expert, to decide and to make decisions with knowledge.
And Clive, as a scientist, you can explain this better than I can as a non-scientist, but the thing that has surprised me tremendously over the years when use the term data. Okay, there's the raw data that comes from an instrument. And then how do you actually interpret that data based on previous models or Earth analogs or whatever the case may be? So I think you were alluding to that second level of data where it's already had some level of interpretation.
Well, let's think it through. Antonino started it with standards. How can we trust the data? And that's what the PI-led mission is supposed to do, and that's why they hold on to it, is they analyze it and they process it so that they can trust it and it can be put out there. There is going to have to be a streamlined way of doing that, but it requires standards to be adhered to. And I'm thinking, as you were speaking, Abigail, you just set up a really good session for next Space Resources Week about what are the next data sets and how do we integrate them with what we've already got for different resources. Because that then shines a spotlight on what we need. But within that is, how do we streamline the processing so we get credible data, usable data that can be integrated pretty much seamlessly without having to check it, massage it, reformat it. I mean, you know, geophysics. If you want a different answer, let them reprocess it. I mean, and we don't want anything like that. We want to be able to understand the data. Any geophysicist in the room? I was being facetious, a little bit. But we need to move forward, but it needs to be in a coordinated way. It needs to be with a campaign mindset, and it needs to be with a laser focus on the next thing that is going to make a difference, not the next thing that's going to be a major scientific breakthrough, although I'd like that, but that's not where we are right now. So we need to get out of the mission mindset. This is exploration science, because it's going to be exploration-focused science in order to conduct exploration where the exploration-enabled science will get done and get done in abundance.
Yeah, so that kind of ties into something that we actually had discussed a little bit before offline here, which is, I mean, is there still a difference between science and resource exploration?
No.
No.
Well, I would say slightly differently. And again, as a non-scientist, I can make this joke. So early on, you know, when I was working with scientists and resource exploration folks, it was kind of like the difference I saw in missions myself was a science mission may have a rover and it's going around and it looks for the things that are really unique. It's like, oh, that's really cool. I'm going to go over and take a measurement of that. Oh, that's really cool. Whereas you know, if you're doing resource assessment, it's mostly plodding along, taking multiple samples, whether it looks cool or not. You're building that statistical data set. So a colleague of mine, Julie Kleinhens, led a study called LWIMS, and it's been published, where we had scientists and engineers and resource folks look at that question of what is applicable to resource exploration, what is science. And there was a bulk of things in the middle that, you know, were common. Now, there were unique science things, there were unique resource exploration things. So Clive is right for 80% of what we're doing. There's no difference. Slightly modification in terms of how you do it, the operations and the type of data and the amount of data you take. That's the key. To do what people have been talking about, resource evaluation and is it a reserve, the amount of data is staggering that you're going to have to take to do that.
And I think that's also now what's really exciting about the time right now is that the scientists and engineers and the venture capitalists and the commercial companies and everybody can get together now, and we're working on one major goal of learning some more about the moon. Right?
I have one quick comment. It's like, it's really interesting because I'm agree with both. and it seems...
Yeah, it is hard to talk between Clive and I.
Yeah, no, it is counterintuitive. But actually, it's like I think that is science, but at the same time, maybe we have to reframe the way of thinking if science versus resources or wherever. Maybe what we should start thinking is like, what is the objective of this campaign or this mission or wherever, this strategy? What are the questions that I'm trying to resolve? And if we just go there, it's like, really doesn't matter if it's science or it's the thing. I mean, it's going to inform science always, that for sure, because more data is going to give us more information and more knowledge. But also we are doing it something very specific that requires a specific set of objectives and goals. So I think that it's a little bit of both, and I don't like to choose, so I prefer like thinking in the mission objectives way of doing it.
So Gary, you'd like
Yeah,
to...
I think the key difference is that it's the same difference as what we call a resource and a reserve, right? A resource, you characterize what resources are there, but in order for it to become a reserve, you must prove, especially a proven reserve, you must prove that it can be extracted, right? And that involves a very different set of experiments and data. You actually have to have mechanisms for extracting it in an economical way. So as we move from science missions that are primarily characterizing resources into more exploration missions, we need to actually do engineering experiments too that are cracking the resource out of the regolith.
And I think given how expensive and technically challenging it is to go to the moon, we cannot afford to be exclusionary or binary, right? It doesn't have to be either or. Things and missions should be multi-purpose. To the extent possible, we need to incorporate science objectives, exploration objectives, purely commercial objectives in mission architectures that are integrated. Because we cannot just afford to do it one at a time. We have to go together.
I absolutely agree with that, but there are petabytes of orbital data from the moon. There is a lot of data there. And we can tweak it, we can get better resolution on neutron data around poles, but for some ground truth data, and if we can integrate those petabytes of data to show where to send those surface assets to look at 12 different places, then we start to get the statistics necessary at the granular level to calculate cutoff grades and reserves and so on and so forth. So it's going to be an integrated approach, but I come back, it has to be coordinated internationally because it's going to take the international community to do that, and that means the international commercial community to do that.
Okay, yeah, and one question I want to pose to both Antonio and Gary before we move to some questions from the audience is, what lessons can we learn from the terrestrial data ecosystem that we can now then start to apply to the lunar ecosystem?
Okay, there's a lot of lesson learned. So in the past couple of years, thanks to my friend and colleague Carlos Espejel from SpaceRS and previously iSpace, I've actually learned a lot about how terrestrial mining works. And the fact that we really need to look how things have been done there and not try to reinvent the wheel or to do it in a way that is completely unrealistic. And so one thing that I've learned is the standardization aspect. Again, you cannot expect an investor or a government or anybody who has some seriousness to believe just one company or just one actor without any validation from the community in the form of a standardized process. This is not going to work otherwise because, frankly, we're not stupid, right? We're not going to give you investment of millions or billions of dollars to do something that is unproven, that is not credible. I think what Clive said before about credibility is crucial. And the mining industry went through this process. I remember Carlos' presentation when he started with the idea of LORS, the Lunar Ore Reserve Standards. He talks about this accident where someone claimed that they had discovered a huge gold deposit, and it was all tampered data. It was all fake because there were no standards on how do you do prospecting. And someone had to jump off a helicopter, and people lost their money, and there was a huge scandal that could have destroyed the mining industry, and it still hampers its credibility. We don't want anybody jumping off a rocket on the way to the moon, certainly. So we're not going to repeat that mistake because nobody will let us do it anyways, right? So I think we need to learn in terms of the standardization and the regulation aspect. That's another element, right? The mining industry on Earth is heavily regulated. It's one of the most difficult activities in the world, and therefore it's one of the most governed. It's going to be similar to space mining. We'll start with less rules because we know less, but it cannot expect to do such an activity on a best guess case scenario, right? You will need to have rules because it's in the best interest of the miners themselves to protect their investment, to make sure that what we're doing holds up. So I think those are some of the key lessons learned.
Yeah, and I completely agree. Related to standardization, the point that is key for commercialization as well. Because, I mean, we are doing our own prospecting mission for helium-3 simply because we have no choice. But it would be much better to have international missions that have scientific standards, because at some point, without that, in order to do any large-scale resource utilization on the moon, will require a gigantic investment, billions and billions of dollars. At some point, like on Earth, that type of investment is done primarily through debt financing, through project financing. And you have the fact that there are standards. When you go to banks, you don't have to say, just trust us. This is going to work. The resource is there. Instead, if it could point to a scientific standard, peer-reviewed, and with enough scrutiny that those institutions, which are very risk-averse, they don't make their money with high upside equity returns. They make their money just on interest. And if the companies cannot pay that back because the reserves weren't really there, then they will not loan the money. So standardization, yes, I think is one of the key things we have learned from the terrestrial mining industry as well.
I would like to add one thing to that. Is like we are thinking about what lessons we can learn about the mining industry. That obviously a lot, but there is another industry that I want to take the attention that actually we can learn a lot. That is the terrestrial remote observation. So actually, these companies, many are commercial. They are having satellites all around. They are commercializing that data already. So I think that is also, we have a lot of things to learn from that industry as well.
Yeah, and to add to that, there was several conferences at the Ames Research Center dealing with off-world exploration, resource exploration. And one of the presentations really hit me. It was about government roles and resolution of data. It dealt with critical minerals. In the United States, Australia, and Canada were getting together to basically map critical minerals around the world at a certain resolution. And with the idea that you could then have anybody pick from that data set, and it was in a form that anybody could get into. And then that opened up the possibility of commercial companies going in detail for places to go. And so I joked about, Gary giving the 5-meter resolution and keeping the 1 centimeter. That kind of falls, I could see government agencies buying that 5-meter resolution data early on just to publish that level and build this global data set.
I want to piggyback on what Abby said and also what Jerry said. The remote sensing industry is actually another great place to look at, as Abby said, because there are also principles there. There are remote sensing principles developed by the United Nations that say exactly what we're discussing here. So that if you are a country and you're being sensed by somebody else, you are entitled to the raw data. So again, not the final product, not the very, commercially developed one, but the raw data, yes. And that is a very well-developed industry from a commercial perspective. So it is the demonstration that you can have policies for data sharing that are open to everybody and still make money and still have an industry that flourishes and develops. So I think there is a lot that we can learn also from that experience.
Okay, thank you very much for the guided discussion here. I'd like to open up the floor now for questions from the audience. Back over there, do we have somebody who has microphones, or should I run
Anybody
around?
but Steve.
Okay, here we got up in the front.
Hi, Steve Freeland, and thank you. What a fantastic panel, and 5 people speaking unbelievable common sense. So I just wanted to share the experience that we're having, putting the principles together that I've spoken ad nauseum about. And one of the essential things that everybody agrees, we have to share information, we have to share data. We reflect that in words, and then you immediately get the pushbacks. You immediately get the pushbacks in terms of, to the extent feasible, practicable, if it doesn't impact on commercial and confidential, if it doesn't impact on national security, if it doesn't impact on our ability to be there first. So obviously we will find a way. We'll find a way in terms of trying to find the balance. But I look to you and I look to everybody in the audience. You know, what you're saying from all of your different perspectives is absolutely the way that we must move forward. Not just in resources, but space traffic management. You know, we're not going to have a system at all if we don't share information. And space traditionally has been this area where it's a needs to know and it's a competitive basis. And space resources, because of the geopolitics, is as much competitive, not just between commercial entities, but between groups of countries. Hopefully that'll change. So I look to you and I look to everybody to keep that message going. And how do you think is the most appropriate way to set a standard of sharing that is acceptable to competing and vested interests around the world? It's really an open question to everybody. Thank you.
Yeah, as Stephen was speaking, the hamster jumped in the wheel and started running pretty hard. So while he's in there running, I just wanted to say that we've talked, Antonino brought up the idea of standards. Standards is a very complex word, but it's something that's not insurmountable. And the other thing you mentioned, Antonino, there's another UN lunar conference, 3 days. And we need to talk about standards for prospecting data. Not the standards, get down to the nitty-gritty of standardization of this, that, and the other, but what are the levels that must be shared immediately once validated versus the levels that can remain proprietary for a given period? How long is that period? And we need to come up with something to iterate from. And that's the whole point, is to get a basis for discussion rather than nebulous discussions that go nowhere. And I think we can reach that, what you're talking about. But we need to broadcast it far and wide and get the input. And I hate to say this, but I've learned from Professor Freeland here, because this guy has the patience of about 20 saints. So, but we need to get people to push back on it, iterate it, make it better, but we need to have something to iterate from.
Yeah. Well, besides standards being a difficult term, data itself is a difficult term, because we've all talked about, you know, the quality and the quantity of data, the resolution of data. Is it commercially viable data versus non-commercially viable? There's lots of nuances there. So I can understand why you want to put nuances in there. But I think we have a lot of examples today in terms of, for example, Landsat. The US government puts out Landsat data and has done that, for decades. But it's at a certain resolution that allows people to use it for certain things, but it's known not to be perfect to the resolution that somebody really might want to. And that opens up then the commercial market. So what you share, you could always share certain amounts of data, certain things. It's where do you draw the line in terms of intellectual property, or that it is of business strategic value?
Yeah, two things. One, to Stephen's question, right? How do we set the standards? Again, here we don't have to reinvent the wheel. There are standards organizations in the world. There is the ISO, the International Standard Organization, which is now hopefully going to house the discussion on LORS, on the Lunar Oil Reserve Standards. That's going to be promoted by ILNAS, by ESRIC, by other standard organizations in the world. ISO has a very well-defined process to bring contributions from experts from all over the world, from institutions, from governments, from industry. So I think that will give us a house to discuss in the very technical aspects of the standards. It's also a very long process, and in the meantime, we can lead by example. I think we should not be afraid of getting these things wrong and therefore do nothing in the fear of, like, we are not doing the perfect example of it. And so, again, what we're trying to do with ESRIC, and I think what the campaign that Clive describes wants to do, what Interloon is also doing, is having a first attempt, right? And see, this is what we learned, this is how we've been doing it, and we can change it, and we're open for that. So that's what we call adaptive governance, right? The idea that we start with what is the most pressing need, with the information we have, the instruments we have. We give something to chew to the member states, to the rest of the community, and openly and intentionally we evolve it until it becomes good enough. And I think that's the only way we go about it. Otherwise, we will be sitting here for 20 years waiting to have the perfect solution, which will probably never come.
We're going to have to do some work, is what you're telling me. Yeah. That's my message.
Yeah, Clive, you can't retire yet.
Okay, do we have any other questions from the audience? It's your chance to ask.
I'm Alexander Lingle from Intel. It's a pleasure to be here. We were talking so much about data, and I was just curious about the standards of data, but there's also the other aspect. If you think of data as oil, as a metaphor, there's the refinement of the data and the pre-processing of the data that has to be done. What standards is being discussed as far as the processing of the data after the fact is collected? I'm just kind of curious what the panel has to say about that.
Yeah, we were discussing that last night at dinner about, okay, you've got all these data sets that are going to be integrated. How are we going to do that? What are the standards? And fortunately, we had Laszlo Kessler from USGS at the table, and he said, well, we've been thinking about that quite a bit, and we have a platform put together. It's going to need some iteration, but we have something built that we can iterate from. And this is why virtual conferences don't work, because you don't have dinner with people, and you have those conversations, and you have those side conversations. Yes, we can have a panel discussion, but most of the aha moments will come out when we have coffee.
So again, I go back to data is not data. You know, there's multiple layers of data. So there's the raw data, then there's the, interpretation of data. And then there's the layering of data. There's been several presentations where, I take thermal data, neutron data, solar data, and how you overlap them. Some of that can be done in some of the models that are publicly available. Others companies are coming forward in doing that, just like on Earth. And what will really be interesting is if you're really interested in establishing a mine, it's not just where is the resource, but where do I set up my infrastructure? Where's my power? Where's my, logistics hubs and things like that? Those are very highly tailored layers that, again, I foresee companies coming forward and doing something along those lines to support other businesses. So I think, again, it goes back to there's certain things that will be available to the public, and just like, Earth observation data, there'll be companies that come out and say, hey, you got a problem, I can do the modeling for you. Or
Abigail.
I have also, it's kind of a question also for my co-panelists, because talking about these multiple layers of data, and just in the session before, we are seeing like a lot of people who are starting to use AI tools and machine learning to actually work with the data. And that also can bring some issues. For example, if you have commercial data, but you just release to some resolution, it's like actually with these new technologies, you can actually use super resolution techniques and things to actually improve it. So it's like cheating. So it's like, I think that kind of things also needs to be into account, that we are not just talking about maps and things, but also new technologies. And that this has been so complicated, I can imagine. So I want to ask to my co-panelists what they think about it as well.
Well, the one thing that I'm semi-excited about, so companies have come up to me and said, I can show you where the ice is in this crater. I've developed the model. And, they have their techniques. Really, it goes back to the ground truthing again. And so in this LWIMS study that we talked about, as you gather the data, you increase the fidelity of your models and you check your models. Where did they correspond? Where did they miss? Oh, I'm going to get another data set to verify that. So that's my thought, is it's not one or the other, but it's going to be an iterative, and the faster we do this and the more integrated we do this, the better the models are going to be and the better the data interpretation.
Yeah, you're absolutely right. It's iteration of the model. I mean, an AI model is only as good as the data set that's in there, and the data sets that are in there, and we'll find limitations. And the beauty of AI is I'm an old fart, and I just trust I rather than A. So they do it faster. All right, they do it faster. So we can get to see the limitations of the data, and it puts a focus on those data that we need to get now, and we've now got a ramped up launch cadence. If we are prepared with our campaign, then we can go get those data and fill in those gaps a lot quicker. So that to me is the advantage of A instead of just I, is that it does it quicker. And it allows us then to move a lot faster than we have done with the glacial science mission.
I want to add another point, which comes from what Clive said when he mentioned Laszlo and USGS, that on Earth, again, coming back to the lesson learned from terrestrial mining, the initial prospecting is done by public institutions, by geological survey. They conduct the missions, they get the data, they have the public maps. We don't currently have a lunar geological survey. Maybe one day we'll have one. But the question comes to, if we want to do these prospecting activities, if we want to do the maps, Clive said, USGS has the platform, we need to run it. How? We need funding. So that's another aspect that I think it's important to highlight. If we all agree this is important, that needs to go forward, we also need to gather some funding. And I think at the very early stages, we're not talking about huge amount of funding, but we do need to find and dedicate resources to do this properly. Otherwise, it will not get done, or it will get done cheating. As Abigail said, someone with AI goes and say, oh, I figured it out. And then we actually gonna go back to square one if we cannot trust this kind of processes.
Okay, so we're getting back to the final few minutes here, and we kind of got back to the data gaps and the ground truthing that we started at a while ago now. For the last round, I just would like everybody to say, what goal would you set for this community to achieve by next year? Or what do you expect to see achieved by next year?
Well, I'll actually let Clive start.
No, I'm not starting. I went first when we started.
I mean, I'm both optimistic and pessimistic. I'm hoping that the messages that are coming out here from this panel and other activities reignites the idea of coordinating missions. And even if it's a one-on-one or more, I am very hopeful, working with Antonio and Stephen, that some of the things that we do here go forward into UN languages. One thing that I was going to say is, I think if we start establishing norms of how we do these missions and how we share the data, that alone will start helping things. So, I try to be optimistic and see the things that are going around. And I think now being in Luxembourg, into a very international community, I am hoping to foster a lot more international efforts than I was ever able to do at NASA.
Yeah, and from the ground truthing perspective, we really are on the verge of a lot happening. So I think I would like to start seeing the real results from that. I hope we'll have much more data and to talk about at the next Space Resources Week. And I tend to feel that sometimes things, in terms of these questions that seem much more abstract and academic, they tend to start working themselves out when you are faced with the actual problem. I've seen this multiple times in my own career, and having worked reusable launch vehicles and commercial launch vehicle development, there was a lot of controversy around would it ever be possible or legal to commercially license a launch vehicle. And then all of a sudden people started just doing it, and the regulations and the norms and the practices had to follow. So I feel like what this industry really needs is to be faced with the actual real problem right in front of them of live data of, is it public? Is there a standard for it? How do we coordinate? A lot of that will start to happen when we have more and more missions flying and sending data back.
Well, lots of things we wish to accomplish on the legal and policy side by 2027. Actually, it's going to be like a turning year, hopefully a positive turning year, Stephen, right? For us. So I'll start with the ones that I'm in control with, which is the work we do at the Lunar Policy Platform. I'm really hoping in collaboration with ESRIC, we can come up with the first protocols and a sort of seed standards on information sharing for resource prospecting, at least mapping what is the legal landscape for it and what do we need to do to share information and what kind of guarantees we can put in place. Then beyond that, at the UN level, of course, hopefully by the next Space Resources Week, we'll have an agreed initial set of principles for endorsement at COPUOS, ideally at a Unispace conference. Same for ATLAC, discussions on an international lunar mechanism and how this will take place, whether it will also include some functions that are related to resource prospecting. And then, of course, from the UNUSA side, the Lunar Conference hopefully will provide yet another opportunity for what Jerry said, reconcile and close the loop between the technical discussion, the commercial discussions, and the policy-making discussion, which I think is critical because we all need to look at each other and make sure that we're still going in the same direction with an informed approach.
Okay, from my side, I just hope that next year we have better tools to actually inform the decision makers and also the general public about the importance of actually going to the moon and what we are going to do there on the moon. And I'm not very ambitious or very ambitious, I don't know how to take it, but actually I just hope that next year, we are closer to actually an international collaboration and prospecting campaign on the moon. That's my only hope.
Well, I've got 13 seconds. No, we're beyond. I'm late. All right, I'll wrap it up. I'll wrap it up then. So next year, I would like to see integrated prospectivity maps for at least one area on the moon other than the Viper landing site. I think that's possible, but there's a dear colleague of mine once said there are two kinds of people in this world. There's those that go out there and make things happen, and those that sit there and just wonder, well, what just happened? And I hope that everybody in here will go out and try and make something happen in a very positive way in what we've been talking about. Come and talk to us and find out, if you're wondering how, is to come talk to us and let's go make something happen together, because it's a pivotal time where we stand, and I really think that the more positive inputs that we get to this process, I think then we'll be seeing great progress in just a year. But it's going to require effort from everybody. And as I say, don't wait for things to happen, but let's go out and make something really positive happen.
I was going to say one last thing from the
You always have to have the last one. You really are like that.
No,
From the
I get to
norms
have
and
the
the
last
legal
word.
aspect, I hope both Lunar Outpost and iSpace get the remainder of the money from NASA to transfer regolith.
That's a very specific goal, yes. And I'd like to also let everybody know, in terms of ground truth, by this time next year, when we're sitting here next year, the Chang'e 7 mission will have already landed on the moon, and we'll have results from another location near the South Pole about what is there in terms of volatiles. And so I'd like everybody to please thank the panel. We had an excellent time talking with you. And we won't keep you any longer from your coffee. So please come in and continue the discussion with us as you want to.
And thank you, Carolyn.
Exactly. Thank you, Caroline, so much.